We have witnessed how to create a serverless API to read and write data from AWS managed database DynamoDB. API is now available for consumption. In this session, we will discuss what configurations API Gateway provide in terms of security and performance and deployment strategies. Let's first take a look at different options we have at the stage level. This option in here lets you cache your API response that is being sent to the clients, which means until the cache is expired, based on the configuration you provide in this setting, which is in seconds, API Gateway will not send any request to backend. It directly sends the response to clients based on the cache. This helps improve performance of your API by reducing the network latency to make a round trip to the backend, and also reduces the number of calls made to the backend. This will not be helpful if your data changes frequently, but it is particularly helpful if your data does not change so frequently and receive a large number of requests in a given period of time. You can choose the cache capacity on how much response data you can cache, and you can also choose to encrypt the cache data from here, and then the time to live in seconds. Once you enable the cache, you will get an option to manually invalidate the cache. All right, I won't be enabling the cache for the demo. And next, you have throttling options. Throttling is a way of controlling how many requests being sent to your API. This prevents your API from being overwhelmed by too many requests. Let's understand these settings for a little bit. This rate setting in here defines maximum requests you can send within 1 second. If you exceed this limit, you will receive 429 too many requests error. And burst setting in here defines maximum requests you can send at one go, all at once, let's say in 1 millisecond. So throttling works based on the combination of these two settings. Let's say you send 6,000 requests at one go. 5,000 requests are allowed in the first millisecond, and rest 1,000 requests are throttled in 1 second period because we only allow 5,000 for burst. And let's say if you send 12,000 requests at one go, 5,000 requests are allowed in the first milliseconds, and the next 5,000 requests are throttled at 1 second period, and rest 2,000 you will receive 429 error because we limit only 10,000 requests per second. And as a third example, let's say if you send 10,000 requests, let's say 10 requests every 1 millisecond, what happens this time? All 10,000 requests are allowed because it satisfies both rate limit and burst limit. Next, you can secure your API using Web Application Firewall. We have a separate lecture on Web Application Firewall and Shield. They are security services provided by AWS. Please visit them. You can also choose a client certificate, which will be forwarded to the backend if it's a HTTP-based backend. You can create a client certificate from here, and then you can choose them in your stage. Well, this is one way of authenticating the backend HTTP service. Backend will validate the client certificate and make sure the request originated from API gateway before it sends any response back to the gateway. And then you have log settings for the stage in here. These are very helpful for monitoring and troubleshooting your API. You can enable CloudWatch logs in here and the log level from here. And you can optionally choose if you want to log the complete request response data. All right, let's enable this and let's take a look at the sample log entry. Let's refresh our API in here so that it will make an entry in the log. And let's go to CloudWatch logs. You will see a log group with the name API Gateway Execution Logs, and then your API ID, and then the stage name. Let's click on it, and let's pick the latest log stream from here. And here is the entire trace of the request to the API. You can also enable detailed CloudWatch metrics. If you enable, each method will generate the following CloudWatch metrics. They are number of API calls, latency to the API, and the integration latency, that is the backend latency, and then the 400 and 500 errors. You can also enable access logging from here. This will also go to CloudWatch. The main difference between these two settings is that The former one contains the request execution logging, such as what request received, when was the backend called, what is the backend response, etc. This will be helpful for troubleshooting any issues. Whereas this one contains more information on who accessed your API, that is, who's the user, what is the IP address, etc. This will be helpful for auditing purposes. So don't get confused between both. First one is for execution logs, and the later one is for access logs. And you can also enable X-ray tracing for your API. It basically gives you in-depth details about the request so that you can analyze the request for any latencies, etc. And next we have stage variables. You can define stage specific variables, example, your backend HTTP URLs or Lambda function names, etc., which are usually different between development, test, and production, right? These are just like your properties file in Java or config files in Python, etc. You can configure environment specific settings and let your API be generic. Let's add a stage variable and see how it works. Let's give a name as get user lambda function and provide the value as our get user lambda function name. Now let's go back to the resources and to our get request. So instead of hard coding the function name in here, we can parameterize this and let stage variables decide which function to call based on which stage you request. This is how we access the stage variables, dollar and the curly brace, stage variables dot, and then the variable name. This pop-up in here is asking you to provide access for your API on the Lambda function, what we have seen in the function policy during our last session. I don't need to add it in here right now because when we configured this method for the first time, I hard-coded the Lambda function, right? So API Gateway added permissions on this given Lambda function. But during the initial method creation itself, if you provide the stage variable, API Gateway would not know to which stage you would deploy, and hence it would not know what would be the Lambda function, right? That is why it is warning you to provide access on the Lambda function by yourself, because it would not know to provide it by itself. So please make sure you provide valid privileges if you're configuring stage variables during method creation itself. So let's deploy the API to prod. Watch closely here. I'm only deploying to prod, not yet to the development. Now, if I go and refresh my prod URL, it should work. And it works perfectly. To be sure if you are receiving the stage variables, let's take a look at the event entry, what we have logged in the Lambda function. So let's go to CloudWatch and to my Lambda get user function log group. Let's pick latest stream and let's expand the event. And there you see the stage variables in the event. I have added stage variable only to prod stage. It does not exist in development stage. If I go to the development stage and to the stage variables, you see there's nothing in here. So let's deploy the API to development stage now and see what happens. Let's go back to resources and to actions and then to deploy API. Now let's choose the stage as development and click on deploy. Now let's hit the development stage URL. And you see, request failed with an error. It doesn't understand the function name parameter. So using stage variables, you can keep API as generic as possible and configure environment specific parameters within the stage. And next we have SDK generation. The cool thing with API Gateway is that it also provides you an option to generate SDKs for your API in the following programming languages. So if the consumers are using any of these languages, they can avoid all the overhead they need to handle in creating and making REST client calls. Let's see an example of Java SDK. Let's give service name and package name and click on generate SDK. Let me open the SDK package. You can see it is basically a Maven project with a source code to consume the API. You as a consumer just need to add the SDK to your code and simply make calls to the respective methods. That is it. And next, you can export your API as either Swagger or Open API format. Well, they both are JSON or YAML files, which contains the definition for the API. Let's choose Open API and export as Open API and select JSON. Let's open this JSON file. You can see the resources, models, method type, responses, etc. Remember in the previous session, I was talking about creating an API by importing Open API or Swagger file, right? This is the type of file we need to import. So let's quickly see what I mean. Let's click on Create API in here and choose Import from Swagger or Open API 3. And let's choose the JSON I just exported. And let's click on Import. You see, a new API has been created from the JSON file with all the resources. So if you have any existing APIs on premise and would like to import them to API Gateway, just create a Swagger or Open API JSON file and just import it like this. All right, let's delete this API to avoid confusion. And next we have deployment history information. You can see all the deployment details in here. And then we have documentation history. You can create documentation for your API from here, which will help consumers to understand your API and what each of its method do and what are its requests and responses. And then we have something called as Canary. This feature helps smooth deployment for your API. Suppose you developed an API, you tested it with your test data and everything looks fine. So you deploy it to production stage. However, there would be some issues which would only happen in production due to the nature of the data or network traffic, which you cannot reproduce in your test environment. If you have been working with production applications, this is a common problem that you have faced, isn't it? Well, with API Gateway, there is a way to get around this problem. When you have this Canary deployment enabled, whatever you deploy to this stage, the changes will be reflected to the Canary release, not to the actual stage release. So you can configure percentage ratio here so that requests sent to this stage URL will be separated into this configured ratio. Let's say we configure 20% to Canary and 80% to this stage prod. Whatever request you send to this URL, 20% out of it will be sent to Canary, where your new changes are reflecting. Rest 80% will be sent to the production stage, which will not have your latest changes yet. So when you enable CloudWatch logs, whatever requests you send to this 20% will be logged into a separate log group within CloudWatch. You can monitor the logs and the requests for some time. And once you feel the deployment is good, you can promote the Canary release to actual stage release. When you do that, this will update the stage with Canary deployment and set Canary percentage ratio to 0. So now whatever requests are being sent to this URL will be sent to the stage, and the stage contains all the latest changes. This way, you can smoothly release your changes without affecting all your users when an issue occurs. Well, let me delete this Canary. One last thing to note at the stage configuration is that you can override few changes at each method level as well. If you go to any method and select this radio button, override for this method. You can change CloudWatch logging and throttling settings from here. All right, let's quickly take a look at other configurations for the API. Under authorizers, you can set up authorization of the request sent to your API. We have two different types of authorizers, Lambda and Cognito. With both the options, we send the authorization token that is being sent in the request to either Lambda function or Cognito user pool, and they validate the authorization. If valid, the request would succeed, else it would fail at this level. And under gateway responses, you can customize the error messages and their codes or add additional headers to be sent along with the error response. And remember, if you make any changes to these responses, you must deploy the API for the changes to take effect. And under resource policy, you can control access to your API on who can invoke APIs or who cannot. For example, this policy in here will deny the action invoke API if the request originates from any of these IPs for this API method. And under dashboard, you can see CloudWatch metrics for different time periods. These are the metrics what we have discussed when we were talking about logging for the stage. All right, let's now take a look at API gateway level configurations. Well, usage plans in here is very helpful in segregating different customer access. If you would like to release the API as a product offering, you can create multiple usage plans for different customers. Let's say customer A is a highly valued customer and you should allow more requests as it brings more business. You create a usage plan, configure higher throttle rates. And with customer B, you do not have much of a business, so you only allow certain requests per day. To ensure that you are not overwhelmed with requests, you create another plan with lower throttle rates this time. Let's take a look at an example here. Let's give this usage plan a name and define throttle rates. And let's also define a quota, an upper limit. Let's say 100,000 requests per month. Now we need to choose the API and a stage to which this usage plan will apply to. Typically, this will be a production stage. So let's choose prod. And from here, you can choose method level throttling for the usage plan as well. This overrides the main usage plan settings. And then we add the API key to this usage plan. Well, what is an API key? We created a usage plan. All good, right? But how does API gateway know whom to apply these settings and to which request, which usage plan should be used? API key will help in here. So basically, you create an API key and add it to a usage plan. Let's create one, give it a name, let's say customer A, and hit save. All right, we have created a usage plan for customer A with specific settings. Click on done. And if you go to API keys in here, you can monitor the usage for each customer on how many requests made. And if you go to the API key section on the left menu, you can also create the API keys from here. Let's click on customer A API key. And from here as well, you can add the key to the usage plan. All right, we have created usage plan and API key and associated them together so that when a request comes from customer A, this usage plan settings will take effect. But how does the API gateway know if a request is coming from this customer or not? What input defines that? The API key in here dictates that. We share this with customer A and they need to send the request with this value. We will see that shortly. But our API right now works even without this input, isn't it? How do we ensure the API only works if this key is sent? Let's see that. Let's go to resources and let's go to our get method. And we need to enable this setting to true so that this method only works if the request contains API key. With this value as false, let's check the API again. And it works, right? Now let's change the value to true. And let's deploy this to prod stage because that's the URL we are accessing. And let's refresh the URL again. And you can see the request is forbidden. Now let's see how your customer should access the API with a given key. Let's go to Postman, paste the get URL, and let's quickly send. And we get the forbidden error. Let's go back into the API keys and get the API key value from here. Let's go back to the Postman again and add a header with the name X API key. This is the header name API gateway uses to identify if the request is coming from the configured API keys or not. Let's paste the value in here and let's hit send. And there we go. We get the response now. Well, uncheck the header and hit send and we get the error again. All right, that is it about API gateway. Quite lengthy topic, isn't it? But it's worth it. API gateway is an important component in development landscape and very important from examination point of view. Few important points to remember is that API gateway lets you build APIs in two protocols, REST and WebSocket. And you have multiple integration types, which are backends the API gateway sends the request to, such as AWS Lambda, AWS Service, HTTP endpoints, mock, and VPC link. And then we have three types of endpoints, which are edge optimized, regional, and private. I suggest you practice with examples shared in this demo and do hands on until you familiarize with the API flow and configurations.